Good morning, mathletes. Dave Staublin here, and we're going to get out our foldable and we're going to take some notes about translating exponential and logarithmic functions. So go ahead and get out your foldables, and if you need to pause the video at any time, please feel free to do so. I am going to open this up, and we are going to take notes on two sides of this page. The first side is going to be translating exponential functions and we're going to introduce some new terminology here. The first thing is that we're going to talk about what is called a parent function, and for us that just means our y equals a b to the x, like this. Now here's the next formula. I'm just going to write it out and then we'll explain what all the terms mean. So if this is the parent function, this means that it's really centered at the origin of the coordinate system. The translated function is going to look like this. It's going to look like y equals plus or minus a b to the power plus or minus x minus h, and then back down below plus k. And so here's what all these terms mean. This plus or minus in front of the a tells you whether to reflect over the x-axis. So if it's positive, it's normal like we know. If it's negative, it's a reflection over the x-axis. Okay, going to the exponent, if it's positive, it's a normal graph like we're used to doing. If it's negative, it's reflect over the y-axis. And then the next are the two translations. This h value is to translate left or right, and what's going to happen is, because this is negative, say that you want to translate to the right, well, that would be a positive number. Well, when you put a positive number in for h, you've got this negative, so it's going to turn it negative. And so what happens is, when you look at the equation, the translation is going to occur opposite of the sign. Okay, the last term here is the k, and this term translates up and down. And because there's a positive in front, if you plug in a positive number which would translate up, it stays positive. So these translations are the same direction as the sine. Okay? So, let me show you what this might look like. Alright, I am going to just sketch a curve in here. Okay? And we are going to, I'm going to use a little different color here. Let's see, this is an exponential, so let's say that the curve, the exponential curve, looks like that. Guess that doesn't look like blue, does it? So this function we'll just say is y equals a b to the x. Alright, now here comes the trick. I'm going to use a little clear piece of paper here, and I guess it's not paper, it's transparency paper. So there's the coordinate system, and there is our function. Okay? So let's say, I'm going to pull that back off a minute. Let's say that we want to graph y equals a b to the x minus 2 plus 3. Oh dear, you're not able to see that, I'm sorry. Alright, let's see if that makes it better. Okay, so there it is. So, what we have is a negative 2 up here. So, negative 2, we're going to go right and left opposite of the sign. So this is going to be right 2. And this is positive 3, up, down, same as the sign. So this is going to be up 3. So 1, 2, 3, 4. 1, 2, 3, 4. So here's what we're going to do. What this would mean is that we would translate everything 1, 2 to the right, and 1, 2, 3 up. And so that would be the location of the new exponential translated. Okay, so that's basically how it works. We're just translating everything around. So you probably won't have one of these, so this is how I would approach the translation if I were you. I would say, I would first identify the parent function, and then I would identify the translations, and before I do the curve, I would translate the coordinate system. So I would say, okay, I'm going right 3 up 2, so from the center, from the origin, I'm going to go right 2 up 3, so the new origin is right there, and I would just dash these in. In a sense, that's the new coordinate system. And then, let's see how the y-intercept goes up 1? I would go from the new origin up 1, and you can draw the translated function. Okay? So that's how that works. I'll tell you what, maybe it will be helpful now to do the logarithm. So let's switch over to the other side, and we'll title this side Translating Logarithmic Functions. Okay, and we're going to do the same thing. We're going to do the parent function, which for logs is y equals log base b of x. And then we're going to do the translated function, which looks like this. Y equals plus or minus log base b of plus or minus x minus h, close parentheses, plus k. And let's identify what all of these extra pieces of information signify. So first of all, the plus or minus in front of the log tells you if you need to reflect over the x-axis, and you would do that reflection if it's negative. The plus or minus in front of the x tells you to reflect over the y-axis. So if it's positive, it graphs regular. If it's negative, it reflects. And then the h tells you to translate left or right. And because this is a negative sign, if you wanted to translate to the right, you would plug in a positive number, and a negative times a positive number is negative. So the bottom line is the translation is the opposite direction of the sign. And then lastly, the k value tells you to translate up or down, and the up or down is in the same direction as the sign. Okay. Alright, so here's what this is going to look like. We'll do a coordinate system here. And we'll do a log function, which looks like this. And we'll say that this is y equals log bx. And then I'm going to grab another transparency paper. And let's see, here is the function. So when we have one of these translation equations, what we're doing, oh boy, that's very reflective. I don't know. Let's see if I can make this less reflective. Alright. What we're going to do is we're going to basically just move the coordinate system right, left, up, and down. Okay. So let's say, for example, that we have y equals log base b, and we'll say x minus 2 plus 3. And so this would mean it's opposite the sign, so right 2, same as the sign, up 3. So what we would do is move the coordinate system and the graph over 2 and up 3. And again, what I would recommend when you don't have the clear thing like I do, start at the origin. It says right 2, go up 3, 1, 2, 3. Mark that point and put in a new coordinate system. And then look at your original. See some points right there, like that point right there? Well, at the new origin, that point's going to be right there, and we can translate the function like that. Okay, so let me zoom out. I'll let you look at the whole thing for a minute. There's a lot of information there. I've given you a packet of information, and so let me demonstrate a couple problems for you. Okay? So here is page 1 of the packet, and let's zoom in on the very first problem. Now, the instructions say, for each graph, identify the parent function, make a table of values, and identify the horizontal asymptote. So let's go ahead and do that. So the first thing we want to do is identify the parent function. Well, this looks exponential to me. It looks like it is y equals ab to the x. And then there's this extra thing right there. So I'm going to write the parent function, y equals 4 times 2 to the x. And I recommend graphing this. Okay, so let's see. The starting value when x is 0, the y-intercept is 4. And then its growth, because the b value is greater than 1, and it's going to double. So if you go over 1, it's going to double to 8, go to 2, double to 16. If you go the other way, it's going to half to 2, and then half to 1, and half to 1. And so the function looks like this. Okay, that's the parent function right there. Okay. Now, here's the deal. We have to identify now what's the translation. Okay, so here is our formula. So, is there a minus out in front? No, so there's no reflection over the x-axis. Let's look in front of the exponent. There's no minus, so there's no reflection over the y-axis. We have a minus 1, so that's going to be a translation right and left, and it's opposite of the sign, so this is going to be translated right 1. And then there's no additional k value, so there is no up or down, or we go up or down 0. So what we could do is, there's a couple ways we could do this. We could take our coordinate system and we could move it to the right 1. So I'm going to change colors here. We could go to the right 1 and up and down 0, and then from this we could use this as the new origin and graph the parent function. So from here, we know we'd go up 4, and then we'd go over 1 and double, and over 1. In the other direction, we'd go half. Now, I'm hoping what you see is, if you graphed the parent function, can you see how the translated function just shifted, all the points just shifted one to the right? That's how you can do it. So here is the translated function, like that. Okay? Alright, let's look at a logarithm. So I'm going to go to page 3. Okay. And we'll look at number 1. So the first thing we need to do is identify the parent function, y equals log, there's no number so it's base 10, and then log x. So we need to graph that function. Now, the things that we know, you can look back in your foldable about graphing log functions. I know that we had it in here somewhere. Maybe not. Okay, well, anyway, let's graph a log function. Here's the things that we know. From the origin, a log function always goes through 1, 0, and then the easiest thing is the next point. If you know the base number, the next point is always that base number and up 1. So 2, 4, 6, 8, 10, and up 1. That's going to be the log function. Now you can also just go to your calculator and make a table of values and graph those. Okay, now let's look at the translated function and see what we know. There's no plus or minus in front and no plus or minus in front of the x, so there's no reflections. This number right here is going to be a right or left. It's negative, so it's going to go right 1. And then this is going to be the up or down, and so it's going to be down 5. So here's what we can do. We can take the origin, and we can go right 1 and down 5, and this becomes our new coordinate system. Okay, and so we can just graph from this point. So over 1 up 0, and then over 10, 2, 4, 6, 8, 10, and up 1. And that would be our graph. Or, if you graphed the parent function, the penciled one, any of these points, you can just go right 1 down 5, right 1 down 5. You know, any of these points, right 1 down 5. So you can do them like that. Okay. All right, the very last page is kind of the opposite. What you need to do is look at the graphs and identify the equation. So, for example, I see this one right here. See that line? It looks like that's the new origin. So I would say this has been shifted right 0 and up 1. And so you can work on figuring those out. Okay? And then there's some on the back too. Now, I want to go back to the beginning of these, and we're going to talk about one more thing, which is domain and range. Now, domain is all the x values where the function exists, and the range is all the y values where it exists. And so let's look at, for this exponential, for the red one, the translated, how far in the negative x direction does it go? And to me, it looks like it keeps going all the way to infinity. So we would write it like that. X goes all the way to negative infinity. And then, you know, it curves and it goes up, but what's hard to tell is that it's going up at an angle. And so even though it's going up, it continues to go to the right, and it will go that way forever. Now, in the y direction, let's talk about going up. It goes up forever. But when it comes down, it gets near the x-axis, but it never touches the x-axis. It keeps getting closer and closer, but it never goes below the x-axis. And so, in this case, the green x-axis is located at 0. And this green axis, because the function doesn't cross it, is called an asymptote. And so this is the domain and range of the function. Let's look at the logarithm, and let's do the same thing. Let's talk about the domain, which is all the x values where the function lives, and let's talk about the range, which is all the y values where the function lives. And what we're going to do is we're going to look at the red function, because that's the one we graphed, the translated function. And let's ask ourselves, what is the smallest value of x? Well, it looks like it keeps coming to the left, and then there's this green line, and the function turns down. And what happens is it gets infinitely close, but it never crosses. And so this green line is an asymptote. And so the x can never get smaller than 1. And then, you know, to the right, it goes forever. Now, the range, if we look at the range of the red function here, the translated function, it goes down forever, so to negative infinity. And then as it comes up, it turns to the right, and it looks like it only goes to the right, but as it's going right, it is also going up. And as it turns out, it goes up forever. And so that's how you find the domain and the range. All right, I hope that is enough information for you to be able to work on the packet. When I return, I will answer lots of questions.